Hello class, today we are taking a look at some extra practice with relations. The first skill that we have in this unit is creating a table of values and a graph for a particular given equation. So in question A, we're given this equation which says to calculate each y value in the relation, you need to do 3 multiplied by the x value and then subtract 2. So filling in your table of values is as simple as using that equation, so 3 times whatever the x value is, subtract 2. And we just need to fill in the x values that they've given to us. And so we'll fill in that in the first row, the x value is -2. Second row, the x value is -1. Third row, the x value is 0. And the fourth row, the x value is 1. Now, of course, just like any time we are calculating these, we want to follow BEDMAS orders. We'll do those multiplications first. 3 times -2 is -6. And -6, getting more negative by 2 from the equation, gives us a y value of -8. Okay, of course, now you could write that as a ordered pair, where we have our x value of -2 and our output or y value of -8. We can go ahead and graph that. Remember that your x-axis is the one that goes left to right, tells you how far left or right of center you are, while your y-axis is what tells you where you are up or down from center. And so we want to go ahead and graph a point whose x value is -2 and whose y value is -8, and we'll kind of intersect those, and that's where our dot is going to be. Now, of course, we don't ever actually draw those dots on -2 and -8. That's just how we know where our point will be. So our point left or right of center is at -2, and our point up or down from center is at -8, 8 down from center. If we carry on for the rest of our calculations, we'll do all these multiplications. So 3 times -1 is -3, 3 times 0 is 0, 3 times 1 is 3, and our equation says to subtract 2 from the product of each of those multiplications. And so -3 getting more negative by 2 is -5, 0 getting more negative by 2 is -2, and 3 getting more negative by 2 is +1. And so again, we have ordered pairs here that we could write for our points that we need to graph, where we have our x value of -1, 0, and 1, and we have our y value that we calculated of -5, -2, and 1. So let's go ahead and graph those remaining points. For -1, -5, we need to go to -1 on our x-axis, and then down to -5 on the y-axis. For 0, -2, we need to go 0 left or right of center, and then 2 down on our y-axis. And then for 1, 1, we're going to go 1 to the right of center on the x-axis, and then 1 up on the y-axis. Now, of course, we don't need to draw a line through these, but we do know that our work seems correct because we know that whenever it is that we are working with a linear relation, which is everything in grades 7, 8, 9, and 10, we should end up with a nice straight line through our points, and that is a nice straight line, assuming you can draw a line straighter than I can on a tablet. Question B is very similar, so we'll go ahead and we're calculating our y values by doing -2 times whatever x is, and then adding 1. So I'll go ahead and fill in all of those coefficients and constants for my equation. And then I just need to fill in those x values. So they tell me to use x value -2, -1, 0, and 1. Let's do those calculations. So -2 times -2 is +4. We need to add 1 to that by our integer rules. So +4 plus 1 is our 5. -2 times -1 is +2. We need to add 1 to that from our equation, so that's +3. -2 times 0, well, anything times 0 is 0. We need to add 1 to that from our equation, so +1. And -2 times 1 is -2, and we need to add 1 to that. So -2 getting less negative by 1 is -1 for our y value. So let's go ahead and plot our points. We've got x value -2, y value 5. So -2 on our x and 5 on our y. Give us that point right there. Next point is x value -1, y value of 3. So we'll go ahead and go to -1 on our x and 3 on our y. Next point is x value 0 and y value of 1. So 0 left or right and 1 on the y-axis. and then final point, x is 1, y is minus 1, and that will be 1 minus 1. Again, we get this nice straight line through our points. Again, we don't have to actually draw this line, but it is a nice straight line through our points, which is a good sign that we've done this correctly. Finishing up, we've got another grade 8 one here, where we have y being calculated as x over 3 plus 4. Remember that x over 3 is like dividing x by 3, and so we can go ahead and do that calculation just like we always would. Again, I'll set up all my coefficients here and my constants, since those are always the same in the equation. And we just have to fill in the x values we're using. They tell us to do x of negative 6, x of negative 3, x of 0, and x of 3. So let's do our calculations here. Again, remember that a fraction is just like division. So we have here negative 6 divided by 3, which gives us negative 2. From our equation, we have to add 4 to that. So negative 2 getting less than negative by 4 gives us positive 2 for our y value. Okay, next division, negative 3 divided by 3 is negative 1. We have to add 4 to that from our equation. So negative 1 getting less negative by 4 gives us positive 3. Next one is 0 divided by 3. Well, 0 divided by anything is 0. And we need to add 4 to that from our equation. So 0 plus 4 is 4. And finally, 3 divided by 3 is 1. We have to add 4 to that from our equation. 1 plus 4 is 5. So again, if you want, you can go ahead and identify your ordered pairs that you need to graph. We've got ordered pairs of negative 6 for x, negative 3 for x, 0 for x, and 3 for x. And then the matching y's are 2, 3, 4, and 5. So let's graph that. Negative 6 on our x-axis and positive 2 on our y-axis gives us that dot right there. Negative 3 on our x-axis and positive 3 on our y-axis gives us that dot right there. 0 on our x-axis and 4 on our y-axis gives us that dot right there. And then 3 on our x-axis and 5 on our y-axis gives us that final point. And again, nice straight line formed by our points, so we do know that we are likely to have done that correctly. On the back, we're asked to now determine the equation for the relation in each table of values. So this table of values is created by some relation. We want to figure out the equation that would have created this table of values. We then want to verify that our equation is correct by checking that it does create at least 2 points in our table of values. So to do this, we know that our equation of our relation is always going to be y equals some constant times x, and then some coefficient times x, and then some constant. Your coefficient we call m, and m is always equal to the change between the y values divided by the change between your x values. So we need to actually look at those changes in our table. We're going to pick any two columns, and we're going to identify our changes. So between these two columns, x is going up by 4. Between the matching two columns, the y is going down by 8. And so our m value, our coefficient, is going to be the y change of minus 8. Oops. Sorry about that. The y change of minus 8 divided by the x change of positive 4. I don't really know what's happening with my tablet here. And positive 4 divided by, negative 8 divided by positive 4 is negative 2 for our m value. So we can go ahead and plug that into our equation. The number in front of our x, our coefficient, is negative 2. For the b value, the constant of the equation, we want to figure out the y when x is 0. And we can again use our table of values and our pattern to figure that out. To get to x is 0, I would need to do a change by down by 4. Now I know what a change of up by 4 causes. It causes the y to go down by 8. So since I'm going the opposite directions, I'll be doing the opposite change. So instead of going down by 8, this y is going to go up by 8. So 18 plus 8 gives me 26 in that y spot, and of course that's positive 26. Since I know that when x is 0, y is positive 26, I know that my constant is going to be plus 26. So if you were to write that as a finished equation without the blanks or anything, you just write y equals negative 2x plus 26, and that's it. So if we go ahead and verify, it means that this equation should have made this table of values. So if I use an x value of 4, for example, I'm expecting to get a y value of 18. So let's check that that's true. Our equation is that when we have a y equals negative 2x plus 26, and we're going to plug in that if y is 18, it should have been caused by an x value of 4. So let's check that that's true. 18 on this side should be equal to negative 8 plus 26. When we add integers with different signs, we subtract their numbers. So 26 take away 8 is 18. And we keep the sign of the bigger number. 26 was positive, so that's still positive 18. Since this is a true statement, 18 is equal to 18, we know our equation works for that particular point. Let's check another point. So when x is 10, we should get a y value of 6. So let's try that out. In our equation, our y of 10 should, our y of 6 should be equal to negative 2 times our x of 10, and then plus 26. 6, therefore, should be equal to negative 20 plus 26. Again, since we're adding integers with different signs, we'll subtract the numbers. 26 take away 20 is 6, and we keep the sign of the bigger one, which is positive. Since 6 is equal to 6, of course, our equation is correct. Let's imagine that we had made an error and we had got the wrong equation. So maybe you thought the equation was y equals 2x plus 26, for example. When you put in your points, your equation won't work. So you would go ahead and say, okay, well, y of 18 should be made by 2 times 4 plus 26. So 18 should be equal to 8 plus 26. And obviously, that is not true. Right? So if you had the wrong equation, you're going to have an unequal statement. Right? 18 does not equal 8 plus 26, which tells you that you've got the wrong equation for your table of values. Let's take a look at this next one here. So we'll go ahead and again, we want to fill in our coefficient and our constant. For our coefficient, we're going to do our calculation. So we're going to look at our change between our y values. In this table, my y values are going up by 2. And our change between our x values, these x values are going up by 8. And so our m is always the change between the y values divided by the change between your x values. Now 2 divided by 8 is not 4. 2 divided by 8 is less than 1. It's a fraction. So all we'll do is simplify that fraction. 2 over 8 is the same as 1 over 4. Or if you wanted, you could say this is 0.25 as a decimal. Either way, that's going to be our coefficient for our equation. We can again use our patterns to figure out what our x is 0 is. Again, conveniently, we just have to do a hop of 8, which we know what a hop of 8 is. A hop of 8 caused this y value to go up by 2. So if we go down by 8, we should be going down by 2, and that will bring us back to 12. Since that's positive 12, our equation will be 1/4 x plus 12. Again, if you were to just write that, you could write y equals 1 over 4x plus 12. You could write y equals 0.25, which is the decimal version of 1/4. X plus 12, you could write y equals x over 4 plus 12, because of course 1/4 is the same as just dividing by 4. All of those would be acceptable answers. Let's go ahead and verify. So I'll choose the point 16, 16. That means when the y value is 16 in my equation, my x value should also be 16, and I should get a true statement. So 16 is equal to 1 times 16 divided by 4. 1 times 16 is 16. 16 divided by 4 is 4. And since 4 plus 12 is in fact 16, that so far is a true statement. Let's try our next point here, our 24 and our 18. And so let's go ahead and fill in that when y is 18, it should be caused by an x of 24. So 18 should be equal to 6 plus 12. 6 plus 12 is 18. 18 does equal 18. We know our equation is correct for that next point there. We get to number 3. This is a simple equation solving. So remember that in a ordered pair, it's always x comma y. So in this question A, they've given us the x, they want us to figure out the y. This is as simple as filling the x into its equation. So we know that y is equal to 5 times whatever x is, and then plus 12 in this equation. 5 times 4 is 20, and 20 plus 12 is 32. So we can conclude that this missing coordinate is 32. In the case of question B, however, they've given us a y value, so we have to fill that into the y spot of the equation. The equation is y equals 5x plus 12. Fill in our y value is 2, and now we need to solve for that x. Remember, when you're solving, you're going to do the opposite operation to both sides of the equal sign in reverse BEDMAS order. So here's our x. We want to get it by itself. Currently, it's being multiplied by 5, and it's being added to by 12. We need to undo those things in reverse BEDMAS order. So let's start by undoing adding 12. The opposite of adding 12 is subtracting 12, and we'll do that from both sides. 12 and 12 on the right side cancel out, and 2 take away 12 is negative 10. On the left side, we still have our 5x on the right side. Now that 5 is currently multiplying by the x. The opposite of multiplying by 5 is dividing. We'll do that to both sides of our equal sign. That gives us x equals negative 10 by 5, which is negative 2. So we can conclude our point is negative 2, comma 2. Finally, we have a simple word problem. We're told that a hockey team keeps a bank account for ref fees. At the start of the season, the account contains $1,250. Each game, the team must pay the refs $75. We're asked to create a table of values, a graph, and equation of the relation to model this situation. So let's start by thinking about this. We're going to say, let y be our account, or we could say money in the account. And that is going to be our output. And it's going to be calculated based on how many games we've played. So let's say x is the games played. So of course, since x and y do not appear in this question, you need to tell me what they are. You could also use other variables, like if you wanted to say a for account and g for games, that would be fine, but you'd still need to tell me what those are. So let's start by creating a table of values, simple one. So we'll say we have our x and we have our y. We know that when we have 0 games played at the start of the season, we had $1,250. I guess we'll include that y is in dollars. If we've played 1 game, then we had our $1,250, we had to pay or take away $75, and that'll put us down to $1,175 left in the account. If we've played 2 games, then we had our $1,175 from first game, taken away another $75 from that, and that'll put us down to $1,100, excuse me. And so on and so forth. If we played 3 games, then we had our $1,100 from the second game, we took away another $75. That puts us down to $1,025, and so on and so forth. Okay. For our graph, then, we could go ahead and create our axes. We are only going to be concerned about positive numbers of games and positive amounts of money. Hopefully our team is not going into debt paying for the referees. So I'm going to draw my axes focusing on the positive quadrant 1 of my grid. Of course, I don't really need quadrant 2, 3, or 4, since those would involve negative values. Remember, your input always goes along the x-axis, and so our games played will go along the x-axis. Counting by ones is pretty reasonable for this, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so on and so forth, games played. And then that leaves our account balance in dollars for our y value. Now we need to get up to at least 1,250. So I think if we count by 50s, we should get there. 50, 100, 150, 200, 300, 400, 500, 600, 700, 800. Okay, 50s is not going to be quite enough. So we could go by hundreds. That would be 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 1,100, 1,200, and 1,300 there. That's not a bad choice. I mean, it uses up most of our graph. If we wanted a kind of middle ground choice, we might go by 75s or something of that nature. But again, I'm really not concerned with exactly what you choose for your scale, as long as it starts at 0, where the axis is, and it uses up most of the graph. So for our purposes, let's go ahead and use the 100s. So I'm going to do every second line as 200. Obviously, that would be counting by 100s. Every second line being 200 is every one line being 100. And then that is something like that. So let's go ahead and start our graph. When we have 0 games, so right on the axis, we have $1,250. So 1,250 will be halfway between 1,200 and 1,300. So that is our dot there. Next one, when we have 1 game, we're at 1175. So this would be 1100, and 1175 will be a little bit closer to 1200 than it is to 1100. When we have 2 games, we're right on 1100. When we have 3 games, we're 1025, so closer to 1000 than we are to 1100. And again, our dots seem to form a nice straight line, so it seems like we've done this correctly. Last thing we need is a nice title, so we'll just say money in a hockey team's account. Again, your title doesn't need to be a creative writing project, but just have it to have something to do with the situation. Okay. Of course, whatever you put in your table of values could be larger numbers if you wanted, get up to 15 games played, etc. And that can be helpful to think about our equation. So with your equation, you can either think about it based on the context and what's your coefficient, what's your constant, or as usual, you can use your table of values to help you with that. For our table of values, our x's are going up by 1, our y's are going down by 75. So that's going to tell us that as negative 75 divided by 1 is just negative 75 for our coefficient. Now our x value is 0 gives a y value of positive 1,250. So that's going to be our constant there in our situation. The other way of doing that is to recognize your starting value is your constant. So we start with 1,250. And then your changes are going to be your coefficient. In this case, we're paying are going down by $75. Okay, so if we wanted to have, for example, 10 games, we could go ahead and do negative 75 times 10 plus 1,250. That'll be negative 750 plus our 1,250. When we add integers with different signs, we subtract the numbers. So 0 take away 0, 5 take away 5, 12 take away 7, and obviously we would have $500 left. So we could go ahead and say that at 10 games, we have $500 left. And again, if we think about our straight line, it would match with our nice straight line there if we needed to. Okay, so I hope that's helped you with your different skills in relations, graphing situations, making equations, making tables of values, solving equations, finding the equation itself, and of course those graphs on the front page.